Hey, 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 everybody. Welcome to TGIK number 109. This episode is going to be a special one. We're looking forward to some interesting interaction between y'all and the episode here, because what we're going to be doing here is we're going to be walking through how to go about contributing to Kubernetes. And contributing to Kubernetes means a lot of things to a lot of people, and we're going to kind of be bouncing through a couple of those examples in this session. So let's see who you have with us today. All right. So we have Muzaffar. Thank you for the happy birthday wish. I really appreciate that. My birthday was great. I got to spend it with my kid, who has a birthday right after mine. So mine's on the 11th, my kid's on the 12th. And so it's just a big happy fish family. My wife is putting up with both of us and all of our birthday madness, but it's been pretty amazing. Yeah, I hope everybody's having some good home adventures, and I'm hoping everybody stays healthy and happy and out there doing good stuff. Hello from Atlanta, says Alex. Where society is definitely not collapsing at all. Very good to hear that, Alex. Enjoy your kittens, you know. Roy from, Sean Lock Gobble or something. Good to see you, Roy. Roy's a good friend. I'm always glad to see him in person whenever I see him. I'm probably glad to see all of you when I see you in person. We got Lamati signing in. Hello again, Mr. Lamati. And we got Waleed saying happy birthday, Duffie. Thank you very much. We got Mr. Rich Burrows, who has actually got a new podcast out. If you have a chance to check it out, it's called Cube Cuddle. You can find information about it on Twitter. Spelled just the way it sounds, Kubecuddle. If you want to throw a reference link into the HackMD this week, Rich, for links, that'd be great. The notes this week, of course, are at tgik.io/notes. Got Brad. Brad signing in from Fairfax, Virginia. How's it going, Mr. Brad? He's another good friend. Brad just actually had a wonderful talk at RSA just recently that talked about some really interesting security stuff as it relates to Kubernetes. Definitely go check out that video. I think they're all out now, but definitely worth checking out. Tim Downey saying hello from the Bay Area. Good to see you, Tim. We were right here in the same Bay Area. I hope that everything's going well with you. And Donovan from South Africa. How's it is a way, actually funny. It's a colloquialism from Hawaii as well. So it's always funny to see that stuff. Ian from Minneapolis. Alex Barnes from Hotlanta. Also, where society is definitely not collapsing. What else do we have? Lee signing in from Brooklyn. We got Rodolfo, ready to learn. Antoine from Paris. Scott saying hello from Seattle. Seattle just actually had a bunch of the schools shut down, and I think this is actually starting to show up nationwide now. I don't know how far nationwide, but certainly where I am and a few of the other places that I'm aware of, schools are starting to shut down. Apparently not all schools are doing it, but, a bunch of them are. We got some people signing in from Germany, from Mexico land, from the Netherlands. Good to see you all. Martin Borgman, Raimundo, Steve Sloka signing in, Vic Parker also signing in. Wow, we got a bunch of really good participation in this episode. Got Mr. Timmy Carr, Elise from Sweden. We got Simone from Gothenburg, Sweden. We got Dan from a little north of the border. Which border, though, I wonder? And Yatin from Ashburn, Virginia. Got Prasad from Switzerland and Ian from Wales and Mystic097 from France. It's good to see you all. I'm glad you're here. So in this episode, I'm really looking for some interaction, right? And so if you actually have an idea or something that you would like to share that is a tip or a trick as it relates to development or on Kubernetes, and it's complex, or if it involves a bunch of text, feel free to throw it into a new section in the notes. Or if that doesn't work for you, what you could do is put this up in a gist somewhere and then link to that gist inside of the notes. That would also work. But feel free to share your tips and tricks as well, right? Like, this isn't just about my tips and tricks. This is about we're trying to collate out of this like a reasonably decent selection of tips and tricks. So definitely check it out. Mr. Magoo saying hello from South Carolina, and Dennis saying hello from Germany. Good to see you all. All right, let's jump into it here. Boop. All right. So this week on tgik.io/notes, boing. I found this great image for the episode. I was really happy with this because I was like, it's actually the 13th. It's March 13th today, and as you all know, it's also Friday. But we won't say that out loud. It's just Friday in March, you know. And then, so what we have in the week in review is that K8's 118 is now in beta 2. So it's getting pretty close to a release, coming right up on it. Docs are starting to finalize, things like that are starting to happen. Debug containers have landed. If you are interested in exploring what debug containers means, there's actually going to be an alpha command in kubectl, or Kettle, or however you want to say it, kubectl, whatever, that I'm linking to here that I'll actually describe like how that will work, but it will actually give you the ability to spin up an ephemeral container and attach it to an existing container, or to an existing pod, I should say. And what that ephemeral container will do is it will allow you to interact with that running pod. Now, the neat thing about it so far is that the design fits into the model where you can attach to a specific pod, but the ephemeral container will live for the life of the remaining life of that pod. So when you're done debugging, obviously that pod is no longer like the other pods in the set, whether that is a deployment or a daemon set or what have you. And I think the implicit expectation is that you will kill that pod and have a new one come up that doesn't have all of your debug stuff associated. So, I mean, definitely check that out. It's a really interesting new feature, and it enables kind of like a broader use of things like, from scratch, or from, what is Kubernetes? So what is the Google image thing? It's like, they've got some really good, distro lists, the Kubernetes distro, or the Google distro list stuff, which basically means that you're able to compile your application into a container without a shell. Like there's no bash or any of that stuff, which is from an operator, or maybe like from a systems administrator's perspective, it's kind of scary, right? Because like you can't really exec into something that doesn't have a shell. How are you going to troubleshoot this when it's not working? Well, this is actually one of the ways that we're like trying to actually solve that with a project, right? So with kubectl alpha debug, you'll be able to actually attach another container inside of an existing running pod that actually has those tools, so that they're not just like lying around for anybody, including hackers, to use, which is pretty darn cool. So definitely check that out. We got Jimmy signing in. How you doing, Jimmy? We got Saren from Roskilde, Denmark. We got Vabav from India. Good to see you. Mohammed from Morocco. All right, Jimmy. Okay, don't be showing off now. No, I'm kidding. We got Mike. How you doing, Mr. Mike? Good to see you. We got Solt from Finland saying hello. And Dennis from Germany, and Balaz from Hungary. We got a worldwide turnout here. It's really awesome. So the link for that, these are the release notes and stuff. So if you're interested in following what's happening with the release, like every beta will actually have some more output. And these things are good things to keep a track of if you're looking to make the jump to a newer version of Kubernetes. So definitely check those out. This is the enhancement for pod troubleshooting, and it's actually going to get into things like how kubectl debug will work, and the ability to actually use immutable or minimal images. Pretty awesome. What else did I link out here? The KX ecosystem. George put this up, and he showed this to me like last week, I think, and I'm really kind of impressed with it. So what this does, so obviously, trying to solve what's happening with COVID-19 is on everybody's mind, right? And so with the idea of this is to basically, enable you to contribute computing resources to solving, some of the compute challenges around trying to diagnose what's happening with COVID-19. Like, what is it? How can we battle it? Like, all of that good stuff. And so if you're interested in that, you can check out the Folding at Home project just online. But if you're interested in maybe just deploying something that will contribute some compute time, go ahead and deploy this. The neat thing here is that it does actually describe what the default is, right? So it's one CPU core for every pod. And so it is limited. And it's actually going to deploy 2 replicas. And you can adjust that. This is what the manifest looks like. And so just like they were saying, it's actually going to give it 256 megabytes of memory. It's going to give it 100 millicPUs. Requests and limits are not matching, so you actually have some flexibility there. It can use at max 1,000 millicPUs, so that's pretty awesome. So feel free to like adjust that as accordingly, and then get it out there and contribute, like if that's something that's interesting to you. Pretty cool stuff, like using compute for good. I like it. Play a supervillain with Cube Thanos. What's that? Let's check this out. So Cube Thanos kills half your pods randomly to engineer chaos in your preferred environment. Gives you the opportunity to see how your system behaves under failures. That's pretty wild. Chaos is a really interesting idea to me, and I don't know. I'm not sure if I'm completely on board with this particular plan, because what this is going to do is just kill off half, and so there might be some really interesting outputs of that. But one of the things about chaos engineering that I think is really probably the most powerful is understanding like what it is you're going to test, right? So like I think of it sometimes as bringing the science to computer science, right? The idea is, you develop a theory, you're developing some web service, and you're like, okay, well, if the database were to suddenly increase latency significantly, would it completely kill my application? What would the actual failure look like? Let's find out, right? And then you actually you work with a framework that actually provides you the ability to go ahead and test that, and then you validate what that's going to look like in reality, and then figure out like, okay, well, now that we know that, like, what can we do to actually improve the situation? Like, would a circuit breaker pattern or something like that in my code work to improve it? Like, what are the kind of the results of that? And then you go back through that same test again and validate that your mitigation actually helps. Like, for me, that's kind of the direction that chaos engineering should be headed, right? Is effectively incentivize people to come up with theories about the way that things break, validate those theories, learn from them, and then make sure that you're leveraging that same experiment to validate the mitigation, right? So that you can kind of go back through it over and over again. So I think that's actually pretty cool. So that's all we were going to cover in the week in review. Let's get down into what's going to happen here. So this is an overview of what the show is all about this week, right? So the general idea is the web is littered with set up your development environment for cloud native. Lots of them get out of date quickly and need love. And we've actually linked to a page down below, which is related to the way that many of the contributors to Kubernetes probably still go about setting up a local Kubernetes, a local development environment for Kubernetes. And so the goal of this document is the goal of this episode is to actually come up with what a reasonable document would look like. And so George is actually going to be taking a lot of good notes as I go through this process. And if you have ideas, again, feel free to link them in or throw them into the chat, or make sure that you put them into the notes if you're interested in doing that. But this is a community-based channel, and I'm like totally looking for your input. And feel free to throw it in there. And HackMD just upgraded, so they could probably handle the load. So before we get into that, though, there are a couple things I want to cover just in general as we talk about contribution. So let's start there. So contribution to Kubernetes is more than just contributing code, right? Contribution to Kubernetes could be that you're out here on TGIK and you're like helping people understand how things work, or you're going through, or you're in your local meetup, doing a talk on Istio or one of the other ecosystem projects, or you're sharing your knowledge, right? Like there are a ton of ways that you can measure contribution to Kubernetes. It isn't just code. And I want to make sure that we all acknowledge that, right? Like there's a ton of things related to contribution as it relates to Kubernetes, right? Like our goal is to make it so that Kubernetes is actually, kind of boring as plumbing and it's everywhere. It's ubiquitous. And we're doing really well against that goal. But to be able to keep doing that well, we need, folks out there really trying to actually spread the word and get that job done. So contribution isn't just code. It's also contributing your knowledge. It's opening bugs. It's testing things, right? Here are a link to a couple of websites that you can actually go and engage on, right? If you're engaging in Slack and helping people solve problems that they're having with Kubernetes, if you're helping people understand how, what a manifest is supposed to look like, or even just having general discussions around security and all of those things, If you're getting out there and doing talks or even just sharing a blog post on Medium or what have you about this stuff, all of those things are contributions, right? So be aware of that. It's not just code. I know that sometimes code can feel like a very high barrier of entry when it comes to a project like Kubernetes. It's such a fast-moving project that you might feel overwhelmed or that maybe you don't have the right skills or whatever to contribute. But remember that everybody has those skills, right? You have those skills. Those skills could be just helping somebody else understand a problem. Those skills could be improving the documentation. Those skills could be helping translate the documentation into the language that you speak natively, right? There's a ton of opportunity to do that stuff. Let's get into one of my favorite entry points into contributing to Kubernetes is docs. Docs we need more people on docs. We need more people like helping to explain what's happening or contributing to things. And contributing to docs is actually has a pretty significantly low overhead, right? Like you don't necessarily have to know everything about Go or even understand the code base terribly well, because what's happening here is that you're trying to basically express your understanding of a thing in terms that people who are just coming to the project can help understand, that can understand it. Or maybe you want to put up a blog post that has that talks about a use case or some new feature that's coming out, right? So like there's a new feature coming out in kubectl Debug Containers. I don't know if there's a blog post associated with it yet or not, but like that could be your contribution. Explore that capability and like put up a blog post for it. So inside of here, they actually describe content guidelines, style guidelines. They give you some page templates. They give you Hugo shortcuts. And there's also fixing actionable issues, right? So like you can actually go into the issues that are available inside of any of the sub projects within Kubernetes and look for good first issue or help wanted. Let's see if we can find one here. There we go, help wanted. Boop. So you click on that tag where it says help wanted, right? And so now we're in the Kubernetes website subproject within GitHub. We click on help wanted, and we can see that all of these issues are currently open. There's 2 pages of them, right? And this is stuff that I'm certain that many of you could help contribute to, right? There are even some that are actually tagged good first issue. Right. Let's go over to the Kubernetes repo and see what we see. Right, here we have 58 open help wanted and a bunch of good first issues on the Kubernetes repo, right? And so if you're interested in actually jumping in and helping to contribute to Kubernetes, these are some great entry points. And just to be really clear, just to, a little history so we don't like lose people. If you go to github.com/Kubernetes, you're going to find that's the kind of like the parent organization for all of the projects within Kubernetes. The main code base is held inside of the Kubernetes project. There's an enhancement project that describes like how we actually want to, develop new features or deliver on new features with relation to it. The community subproject is a great one to also get involved in. This is where you can go to learn more about the special interest groups that are associated with Kubernetes and those sorts of things. Community also has a really great piece that talks about contribution, and we'll talk about that here in a second. The website, this is where all of our docs are held. This is like where you can actually help kind of explain how things are done. Examples are like example tutorials and those sorts of things. So feel free to jump in and look for good first issues or help wanted in any of these and see what's possible. Obviously, some will have more help wanted than others. Like website definitely will have a ton. Kubernetes will have a ton. Community probably has a bunch. Test Infra I think might or might not have some, but definitely check it out. It's a great first entry. So helping with docs is like a thing that you can totally do, and helping with docs can literally be as simple as like finding a page that, let's see, storage APIs. I just saw one earlier that I was going to try and find here real quick, but like, see, get Kubernetes. Okay, so like it could be as simple as this, right? So here we can see that there is a URL, and I'm actually planning on putting in a pull request for this one, and we might just do that. That describes how to go ahead and get the kubectl binary from the storage location that it's in. Right now it's under storage.googleapis.com/Kubernetes release, but we have a shortcode for that, right? Like this URL is actually also inside of our Kubernetes documentation. We also refer to this as dl.k8s.io. So if I wanted to make a change to this, right, I can go ahead and click on this pencil up here. And then everywhere I see storage.googleapis.release, these things, right, because I know that dl.k8s.io is a thing, I could go ahead and make that change. And this is an example of how you can contribute to docs, right? So I can go through here and actually find everywhere there's everywhere there's a link to storage.googleapis.com, and then change that link to dl.k8s.io, validate that my new change works, right? And then if that does work, then I can go ahead and contribute that that code. Or if I see a typo or changes in docs that actually can be improved, obviously try and find more than just one typo, but like, you know, like try to find something material that you could change. Like don't add a period if there's a missing period, but like, you know, try to find like, you know, go through like a set of the documentation and try and find a few mistakes so that your contribution is like more than just one character. Like get out there and do a little more than that, but like, but you can see how that would be useful, right? So I'm gonna throw this away for now and do that later, but this is what I mean is like how you can go about creating that pull request, right? Contributing to docs, they try to make very, very simple, and that's a shout out to Zachary, who is actually a big part of that, and there are a lot of other people who are working on SIG docs, not nearly enough of them, but like, you know, you can be one of them too. Like I said, if you want to help with translations, that's another thing that we need more of, right? So like any docs that can be translated into your local language would be super helpful. I mean, and you are an amazing audience, and you're dispersed across the entire globe. So like, I mean, literally that could be super helpful, and that's why I'm talking to you today. So now let's talk about like how to contribute to the code base. You know, these are some of the other, you know, some of the kind of, I guess, higher profile contributions. And it's sort of like what people think of as the norm. So if we go to the Kubernetes community subproject within we go to the Kubernetes, the Kubernetes community project on GitHub, we can find the contributor section. And then there's a guide section, and this cheat sheet here, which I think is probably linked in a more useful way, actually describes like some pretty interesting stuff as it relates to how you can go about about contributing to Kubernetes, right? And again, it describes like there is a bunch of different ways you can contribute, including code. And if you're going to contribute code, there are some things that you need to do. Before you get started, this is a big one. You need to sign the contributor license agreement for Kubernetes. Now, typically, you can sign that as an organization or as a person, depending on who you work for and what their local rules are. So here at VMware, I actually have to. My current CLA is under VMware's company license, and I have to actually make sure that I can contribute to that open source project as a VMware employee. And that may be true for many of you as well. But in some cases it may not be. Then we're going to set up your local development environment, and that's actually where we're going to play with here. So we're going to go check that one out. And then the community expectations and roles and how community membership stuff works. Definitely take a look at these two documents as well. Alrighty. So now we're going to look at like how do we set up the development environment. So that was all of the preamble. Now we're going to start playing with the development environment. Let's get this started here. So the document that Mr. George put in for us has kind of a wild set of requirements. So let's check this out. So this document, the requirements are to develop code or to contribute code to Kubernetes. They are Linux, Docker, etcd, Go, OpenSSL, and CFSSL. And they go through like how to set this up. And like it falls out of date, and it's actually quite a lot of work to actually get this done. So we're not going to do it this way. We're going to do it a different way, which is going to be basically leveraging Kind to do a lot of this stuff. And you all know how I feel about Kind. So we're going to go through and see if we can actually understand how that's going to work. So now begins the interesting notes part. The way that we're going to do that is that we're going to go ahead and kick off what it takes today. So today, our prerequisites are Git, Docker, and Go, and those are the big three, right? Like we don't really need much more than that. You can actually have this running on a Mac. You can have it running on Linux. You can have it running in Windows. Obviously, a Linux environment is a little easier to deal with, but when we think about the way that Kind is actually going to abstract a lot of the work for us, it's actually not like a hard requirement that you have some sort of a terminal to do these things. But let's talk a little bit about what I mean here. So let's get started. Boop. Wait. Actually, let's go back to the notes here real quick and make sure I'm not missing anything. How's everybody doing in the chat? Got Sebastian from Tortoise. We got Mohammed from Jordan. Pretty high number of viewers. Yeah, lots of people checking it today, which is awesome. Yeah, home office is going to be a big part of it. Don't touch your face. You're not my real dad. I'm touching my face. I'm kidding. We got Slack server. I believe it's, yeah. There we go. Jim Angel, thank you, sir. Kubernetes -docs-len code. We have Ahmed from Egypt. We got Jim talking about Italian saying Kubernetes is inside of this slack.k8.io. You can go to kubernetes.it. We got Rory saying hello, or sharing his care for Kind, which I agree, and Rodolfo saying thank you to Jim. All right, so let's keep going here. So this is my Linux terminal, and I've got my pretty background and stuff. And so what we're gonna walk through here is like the prerequisites. So the first thing I'm going to assume you have is that I'm going to assume you're going to have Git, right? And you can install Git like through on Mac. You can install it through like the. Anybody want to remind me of what the tools are for Mac? It's like a thing that you could download that allows you to develop things. It'll probably show up in the chat any second now. But if you have that installed, Brew is actually a big part of it. But Brew actually also requires this other thing, which is like the dev tools for Mac. But I can't remember what it's called. Brew is a big part of it. Yes. Yes, Homebrew. Yeah, with you so far. But there's another part. Xcode. Ryan. Yes. So like getting a reasonable version of Git is important, and you can do that through Xcode, and you can also do that through a variety of different ways. But I'm going to leave that to you to like Google search how to get to Git. Git is an important one. You will likely already have it if you're considering a contribution, but Git is super important. Yeah, I'm probably never going to switch to ZSH. I'm going to stay on Bash, but you have that capability. I'm using Ubuntu 1910 on this machine, and it's actually a Mate desktop. And I did that because I really like my wobbly windows. I'm a little old school that way. What did this one? Oh, there we go. I love Linux. All right. So yeah, that's just me. So Other things I'm using for my environment, I'm using Powerline Go to actually set up my my prompt. Powerline Go is really awesome. Powerline Go lets me do things like understand what Kubernetes context I'm in, whether I actually have anything to commit. It does a bunch of other neat things. I'm using a Dell LSHW less. What is this machine? Decode less. This is a Dell Precision 5540. And it's got all kinds of cool hardware. It's like got like 6-core CPU that's all pretty beefy, and it's got like 32 gigs of memory and all that good stuff. That's pretty awesome. It's not an XPS. The one I carry around with me is actually a Lenovo, what do you call it? A Lenovo Yoga 14-inch, and that's my personal machine. But this is the one that I actually use for Kubernetes. So, all right. So we're going to make a new directory here. Nope. Make dir TGIK, cd TGIK. And so again, I'm assuming that you already have Docker. And you already have Git. And the rest we're gonna handle right here in this directory. The way that we're gonna do that is we're gonna use another thing that I like to tell people about, which is called direm.net. Direm is a way of actually loading into your environment things that you specify into a file inside of a directory. Here's a little bit about how that works. You can grab direm. It works on Mac. It works on Linux. It works on your Linux shell that is part of WSL2. It works pretty well everywhere. Inside of my bash RC, I've got this direm hook that I'm using to load this, and that means that whenever I see a file that direm will actually manage, then it will actually take care of it. So the first thing we're going to do is we're going to install Go, because we're going to need Go. So let's do that. And we're going to use direm to do that. Now, the other part that I want to explain, the way that direm works is it's going to load everything that's in your environment and make it real, but the other part that we need to actually be able to make that work is gimme. And let's talk about gimme real quick. Gimme Go. I should have put a URL for this. Gimme is a project that's actually part of the Travis CI thing, and I actually heard about it originally when trying to build stuff in a CI environment. But I've actually been using it locally inside of my Linux environment, and you can run this, I think, in Mac or OS. You know, it's part of Homebrew, so brew install Gimme will get you there. It's actually also just a bash script, so you can actually just grab the bash script and pull it down locally. So let's go ahead and do that. So take dir bin. Bin, gimme to bin. So inside of my directory now, I have a bin directory. And if we look inside there, we can see gimme, and it's already set to executive mode, right? So I've actually downloaded that bash script. And if we take a look at that bash script, if you're curious about it, this is basically going to use bash to download a version of Go. And so if I do help, it'll give me lots of output that is useful to me, but really the end of the most important bit is that it's actually going to set a bunch of environment variables and download and make available gimme in such a way that I can, or Go, a download of Go that I can use locally, right? So if I do Go version right now, it's inherited, so let's do moo.mvars. Just ignore me for just a moment. Okay, so if I do Go version right now, I find that I don't have Go installed, and I don't want to necessarily install the version of Go that is a part of Ubuntu. I'd rather use like one that I can flexibly change. And so I'm going to use Gimme to do that. And so now if I export Gimme into my path, right? So I do export path equals path colon which Gimme unlink user local bin. Trying to clean things up here. There we go. So now we can see the Gimme binary, or the shell script, is being loaded from my TGIK directory. And I'm going to upload all this. This is why I'm doing it all inside of a directory, so that you can actually see this after we're done. All right, so now my path is set. And the way that I did that, again, was just by exporting my path, my existing path, and then appending my bin directory to it. And this is going to be true for Mac. It's going to be true for any Linux environment, whether it's WSL2 or under a Linux machine. Okay, and so now that we actually have our first export, let's go ahead and get our DRM stuff working, right? Clear, so let's do vim.mvarc. And what we're going to do is we're going to export our path variable to include the bin directory inside the directory we're in. And then DRM, because of that DRM hook that I showed you in the bashrc earlier, right, it will say, there is an nvarc here, but nobody has explicitly allowed it, so I'm not going to load it, just in case there's some shady stuff inside there, right? And so because we just wrote it, we know it's not shady, so let's go ahead and allow it. Actually kind of a cool safety feature that DRM has. And now we can see that the path is set, right? So now if we do echo path, we can see TGIK bin is there. And that's awesome. So now we can do which Gimme again, and we can see that it's there. So now we're going to go ahead and install a version of Go, right? So we're going to do Gimme, we're going to do Gimme stable, and then we'll just do that by itself. Yeah, Intel Nix, they're making me nuts. But I'm back now, I think. Sorry about that. So stay with me. So these are a bunch of environment variables that we can see that are the output of Gimme. And I'm actually going to go ahead and I hope you didn't miss anything. It might be that Gimme stable is using all my bandwidth. That's true. So I'm going to go ahead and dump this right into our nvarc. So let's go ahead and do that. And we saw immediately that the nvarc is blocked because it changed. And then we need to go ahead and throw drm allow in there, right? So we do drm allow. And now we have a bunch more variables, right? We can see the gimme env and the go root is set. Now there's one more thing I want to set here to basically make my life a little easier. Let's jump into the nvarc. Excuse me, and what I want to set is this. So we'll do export go path equals drm allow. So now my environments, right? So now my go path is set to my working directory inside of Go, right? So if I do mike dir go, so now I have my bin and I have my Go and I have everything I need to actually get started here, right? So I've already got Docker running, I've already got Git. Now we're ready to start checking out some code. So y'all can see me now, right? Can I get some thumbs up? Oh, did I? Whoops. Ah, good point. Thank you, Rory. You're the best. There we go. Yep. You were correct. All right. And a... Is it really? All right. So we're all fixed up now, right? No more typos. We're all good? Thank you. All right. Okay. So now we got all that stuff set up. We already had Git, we already had Docker, and now we have Go. And the neat thing about this is that if you wanted to pick a specific version, like say you're working with a project that requires a specific version of Go, then you can actually handle that with Gimme, right? So you can actually say gimme-list. I think it's gimme lists, isn't it? -- lists. Unhappiness. There we go. All right. So we got our Go path, but we actually had to be explicit about it. You know, it is what it is. So our Go path is going to be home Cooley TGIK Go, and this could be pretty much any path that you specify. It could actually just be, if you don't specify it, I think it turns out to be your like home Go directory. And there are things about Go modules that are kind of hateful about that. Like you actually have to be really careful about making sure that you specify that correctly. So there we go. We got that. What was the other thing I wanted to check? So we got Go version working. But what I was noticing was gimme-k. All right, so there we go. So now we can see all the versions of Go that Gimme can go and get, right? It can go and get all from 1.2.2 all the way up to 1.14. And if we do gimme-l, we can see that the current version is 1.14. So this is what Gimme provides for us, and I really love that functionality. It's really cool. I actually have 1.13.5 locally and 1.14, and the current version that I have in this particular directory is 1.14. All right. So there we go. Oh, you're right, Waleed, you're awesome. Double quotes would have saved me. Let's go ahead and fix that, because why not? We got time. Boop. PWD. DRM allow. Go version. Oh yeah. Echo. Go path. Working. Thank you very much. All right, so Gimme works. And you can use Gimme to install on a Mac or on a Linux machine. And hopefully if you're going to be on a Windows machine, you could use WSL2 and just do that stuff inside there. All right, so there we go. So now we have Go, we have Git, we have Docker. We are ready to do some interesting stuff. So the first thing we're going to do is we're going to check out the Kubernetes code base. So let's go ahead and do that. So let's do go get, and this is an interesting thing. You might think that the next thing I'm going to type here is github.com Kubernetes. And you would think that because when I go to GitHub, that's actually where I go and find the code base. But in fact, I don't do that. Instead, what I do is this. And I might go away for a second again because the whole download thing, but bear with me if that happens. We'll see how it shakes out. Hopefully you're all still there. Are you all still there? Are you gone forever? Looks like I'm still broadcasting. All right. So what this is going to allow me to do, cool. All right. So what this is going to allow me to do is it's going to download the Kubernetes source code right into my local directory here inside of TGIK, and that will allow me to look at that source code and play with it. And we're going to talk a little bit about like we're going to play with that source code and kind of build it locally and do all that kind of stuff. So bear with us here while this is happening. Shouldn't be long, hopefully. If I did go get -v, we could actually see if it was actually downloading fast or slow or something. But I hope that it won't take a super long time. In the meantime, while we're waiting for that to download, let's go and show you something in the code base, which I think actually will kind of highlight why we use that. Why we use that vanity URL, right? So if we go to Kubernetes. So this is our source code, like I said before. And I think if you just go to k8.io/Kubernetes, does it take you to the source code? It doesn't. It takes you to the documentation, which I guess is good enough. So this is our source code, and the thing I want to show you is like, so if we pull in the command directory where a lot of the commands and stuff are, and we pop open kubectl here, and we look at that kubectl go file, and we look at the imports, this is actually where that comes from, right? We can see that import inside of our go, that go import that's sitting inside of this file is k8.io/kubectl/package. And you know the other part of the import is k8.io Kubernetes package kubectl cmd. Now mapping this in your head, what's actually happening here is that there's going to be a sub-project underneath the Kubernetes umbrella inside of GitHub that is going to be the kubectl one, right? So if we wanted to go and look at package util logs underneath kubectl, here's how we could do that, right? So we go back to the umbrella organization. And we would look up kubectl, and there it is, right? And then there is the util logs, right? And so that is the thing that we just imported into that other piece, right? So when you're looking at the source code and you see an import that says k8.io, what that means is github.kubernetes, and anything that happens after k8.io will actually point to whatever that next reference is, right? So if it's k8.io/Kubernetes, then you're looking at the main project. If it's k8.io/kubectl or k8.io/website, then it's going to be one of those other sub-projects, right? That's actually how that's going to work. So I hope that explains like at least how to think about that import path. I know it can be a little confusing at first, but when you're looking at the code base or when you're looking at actually like pulling in other dependencies, not only just for within Kubernetes, but also like say if you're going to develop an operator or any of that other stuff, right? You have to kind of understand how that maps so that it'll make a little bit more sense and where you can actually go get that stuff. What was our download doing? We're done. We've got it. So don't worry about this error. It's basically telling you that, so when you do a go get by default, it will actually try to build what's ever in there. And if it doesn't find any files in the home directory, then it's like, I can't build it, like whatever. So the next thing I want to grab is I want to grab the kind project, and we'll get into the kind project as well. So let's do that. So let's do go get sigs.k8s.io/kind. So we're going to grab kind because kind is actually going to help us abstract a ton of the stuff in that get setting up document, right? But what's interesting is you can see that I'm doing a go get again, and this time there are actually Go files inside of the root directory of kind. Oh, sudo unlink user local bin kind clear. And if we go into Go, and we go into bin directory, we can see that kind was created. And so we want to make one more change to our envarc here, right? So we'll do vim envarc, and we will append our Go bin path to this, right? So we'll do pwd go bin. Okay, so now if we do which kind, we can see that kind, the binary, is underneath our go bin directory. So we're all still encapsulated right here in this directory, and that envarc basically handles that all for us, right? So now we got our local stuff, we've got kind installed, we've got go installed, we've used go to download and compile kind, right? We just did that when we did the go get of sigs.k8s.io/kind. We downloaded the kind source code, and we also built the binary. Now, and we've also just put that binary into our path. Now, the next thing I want to show you is let's look at that source code and understand how that's going to work, right? So this is interesting stuff. So bear with me here. So the next thing I want to do is, yeah. So we know that this is our go path, right? And inside of here, you can see two directories, bin and source, or bin and source. And the bin directory is like a place where the binaries that are built for Go projects that you check out, like with this particular path, it's going to throw the binaries in there just to make them easier to find. And if we go into the source directory, we can see some other neat stuff, right? We can see the k8s.io checkout that we did earlier, and we can see the sigs.k8s.io checkout, and we can see some other things that are pulled in as part of dependencies for the other things, right? So if I do tree here, whoa, all right, minus depth. Help. Yeah, we go. Tree minus D. That's still not helpful. ls star. Okay, that's a little easier to see. Okay, so we have our directories, right? We have GitHub, Golang, Go package, k8s.io, sigs.k8s.io, and then underneath them, we have dependencies that were pulled in by some other project, right? So these packages could be pulled in from part of the kind project, that could be pulled in part of Kubernetes project. Probably not part of Kubernetes yet because we haven't done any building and haven't built anything inside there, right? So probably all of these dependencies are related to kind because that's the only thing we've really built that would have pulled in dependencies. We can see underneath the k8s.io side of things, we've checked out API machinery, you've checked out Kubernetes. And just like we talked about before, if I wanted to go and find this API machinery checkout on GitHub, the way that I could do that is by looking at github.com/Kubernetes/API machinery. That's where I would find that dependency. And then underneath sigs.k8s.io, that's where we checked out kind, and it actually also checked out a subproject also hosted under sigs.k8s.io, which is called YAML. But let's move on here a little bit. So we got kind here, we got kind version. We can see that kind is like built up against the top of tree. We've got Go built, we've got Kubernetes checked out. let's go over the kind project real quick for the parts of the kind project that we're going to be using. kind.sigs.k8s.io. So the next part I want to show you is basically this node image stuff. And this node image stuff I think is actually probably one of the cooler features that kind has, because it lets you do a thing where you're basically able to build whatever version of Kubernetes you have checked out, including things that aren't committed, and make them and then bring up a cluster based on the source code that you have, right? And that's pretty wild. So let's explore kind of like how that works, right? So the design here is that other than the requirement that that this image inherits from a base image, and by the way, that will be hosted for you. You don't necessarily need the base image pulled down locally. It will be pulled down as part of the build of the node image. Variants of this image have the following properties, right? So there's a kind/images directory where a bunch of the built binaries and stuff are going to be made available. As a systemd service that's actually going to start a kubelet. And this is actually not getting into what I want it to describe. This is probably something I should fix in the documentation here. But when you build a node image, it doesn't really describe it here. But what this is going to do, a node image is going to look for your local checkout of of the Kubernetes source code, and then it's going to build the source that it sees. So let's play with that. Let's get that started here. So because we actually have Kubernetes checked out here, if we have kind installed, we can do kind build node image name, actually image equals, and this is going to be the image name, right? Local, we'll call this master, because that's basically what it is. And then what's going to happen here is that it's going to build the code that's in my local checkout of the k8s.io code repository. And it's going to build kubekettle, it's going to build the kube controller manager, the API server, kube proxy, all of the components that are a part of a Kubernetes cluster. It's going to build all the binaries for those things, and it's going to package them up into a node image that we can use to then stand up a Kubernetes cluster. So let's go ahead and explore that. And then we'll get a little more creative about how this works. I mean, there are some pretty neat things about the way that build node image works, like there's some caching stuff that happens. k8s.io kind. So what you just saw here at the top, if you go to sigs.k8s.io/kind, and that was our import path, right? When we did our git checkout, when we did our go get, we did go get sigs.k8s.io/kind, right? That's also the import path for kind. So if you're going to use kind as a library, that would be the import path. What I want to show you here is inside of the build piece for inside of the build piece, this is basically what's happening under the covers. And then we're going to talk a little bit about like how this actually works locally. So inside of here, these are the build bits. So we're setting some environment variables, right? We're appending kube verbose no, we're setting kube build hypercube to no, we're building conformance no, kube build platforms. It actually tries to determine what the architecture you're on is on and builds it for that. In our case, it's actually we're using Linux, so it'll just build the Linux architecture. We have go flags, tags, provider lists. What this is trying to do is solve some of the provider stuff. And then we actually get into the what's, which is pretty fun. So the what's basically describe like what we want to build and how we want to build it. And the first part of it is actually going to build the binaries, the kubeadm, kubekettle, and kubelet binaries. And then the next part of it, we're actually going to, this is the command that is actually going to be used to do this. And we're going to play with this command a bit to kind of explore what's happening here. But effectively, what's happening here is we're using a shell script called run.sh in the Kubernetes source code that will actually do a make, that exposes a make command inside of a container. So when I'm doing that make, I'm actually running that make command inside of a container. That's what run.sh is going to do, right? It is going to set up a build container. It's going to do a build of the entire source code inside of that container, and then it's going to rsync out the actual binaries that are used, right? The next thing we're doing is we build the images. So the next command we run is make quick release images. That's wild. We don't need that there. That's actually kind of a bug. Like it looks like we're building them twice. Kind of funny. We should only have to build them once. And then, so yeah, that's what's happening in the build. Let's go back to the log and we can see that stuff happening. So the first thing that happens here is that run.sh command, right? So like when you're putting it in here, that's what's actually happening. And there we are building our kubeadm, kubekettle, and kubelet commands, and we sync the content of that out of a container into a temp directory. And the next thing we do is we build the Go targets for the container images that we're going to build, right? So we need the API server, we need the controller manager, we need the scheduler, and we need proxy. And we need all of these as images that we're going to bundle into the actual kind node image that we're going to use to stand up Kubernetes. So we start building the image. We actually delete those images once they're done. This is the temp directory where all of these things are held. And then we start building the actual node image, and this is where we actually populate all of the bits that we're actually going to use inside of the node image. So we also have to pull in a couple of the other prerequisites for Kubernetes, right? So we're going to pull in our base image, which is Debian base. We're going to pull in the pods image. We're going to pull in core DNS. We're going to pull in a default network CNI for kind, which is basically kindnet. And then we're going to pull in the etcd binary. We're pulling in a local path provisioner, which allows us to actually define things like persistent volumes within kind. And then we're going to fix some paths to make sure things work. And then and there we have our image, right? So now if we do Docker images, ooh boy, I have a lot of images. So there's the image we just built, and it's 1.25 gigs. And that is the image that represents our top of tree build. So let's see if we can actually get this thing running. Build, or kind, create cluster, image equals master. And what will happen here is that kind will actually try to create a single node cluster using that node image that we just built to stand up a Kubernetes cluster. And we'll see if that actually works. So now we have our Kubernetes cluster. Now if I do kubekettle version, look, we've learned some interesting stuff, right? So we are running, because we're running on master, we just successfully built v1.19.0 alpha 0, which is what the tag is for the current master. And we stood up a cluster using that master branch, which is always a little risky. So let's actually talk about doing this with a particular checkout of Kubernetes. Like maybe we actually want to check out a particular release, or we want to contribute code to a specific area. So let's play with that. So I'm going to go ahead and delete this cluster. And let's go check this out, right? So now we're going to go into our source code. So clear. So currently we're underneath our TGI directory, and if you check out this directory after this episode is after this episode is over, you're going to be able to actually go through these steps. You're going to be able to follow along. So that's my goal here, is to make sure that you, while watching this video, can go through these steps just the same way that I do. And if they don't work, reach out to me. Like, I'm here to help you, and I am not the only one. We are Legion. We are all here to help you. That is one of the greatest things about the Kubernetes community, is that we're all here to help. Okay. So this is where the source code is right now, and if we move in here, we can see that we're on the master branch, right? And that's actually part of my Powerline Go stuff. So if I do git branch, I can see that I'm on the master branch, and that's actually how it picked up this master branch piece. But let's check out a tag, right? So let's see. We'll check out git version, or we'll check out Kubernetes version 117. Let's see, what's the latest? 117.4. Right, and this is the tag for the release of 117.4. Now, because I've changed the version, right, now I'm actually on 117.4. If I do my kind build node image equals 117.4, then I will actually be building version 117.4, right? And we can see actually that it pulled out this kube build container. This is actually part of the setup of kind. This is actually where the container is actually going to be where a lot of the build is going to happen for your stuff, right? So inside of, if you look at your Docker configuration, you can see that the kube build container has started up, and that's actually where all of this building is happening. It's running inside of a container, which is really wild. Here's our code generation that happens every time we do a build. Then we can see the binaries being built, kubeadm, kubekettle, kubelet, and then we'll be able to see those images being built. Exactly, Bogdan. I am Legion, for we are many. We are all here to help. So what you just watched, I want to make sure that we're really clear about what's happening here. I went into my checkout of Kubernetes, my local checkout of Kubernetes, and I moved from the master branch to a tag of 117.4. And then I'm using kind build node image to build the code from that tag. Nice, waiting for TP pallets to deploy. Thank you, Fernand, that's hilarious. All right, 2:10. We've been at it for about an hour and 10 minutes. I have a couple more things I want to show you before we're all done here, so stay with me for just a little bit longer, because what I want to show you is like maybe a flow that would help a lot of people figure out how to contribute, right? And so, yeah, that's what I was talking about. We're building kubelet twice. We're building kubekettle twice. That's weird. There's a bug in our code here. Master, for some reason we added kubelet and kubekettle back in. I don't get why we did that. So I'll take a look and see what that was about. So we're bundling up our images. I love that we can actually watch this live. That's how long it takes, right? Like it takes that long to build Kubernetes. That is wild. Isn't that amazing? I could totally do a part 2. Anyway, so we got this all built. We'll do a kind create. And now we're bringing up another Kubernetes cluster using binaries that are built from our local checkout of Kubernetes. If I was trying to actually modify the way that code works inside of kubeproxy or any of those things, I could actually just do that right there in my checkout of Kubernetes and bring up a cluster with all of my code checked out to actually validate that this works, right? I mean, that's wild. So now if I do kubectl version, we can see the version that we're checked out into, right? Oh, that's a Git version. Oh yeah, that's right. So Git version is 117.2, that's our tag, right? So I just built 117.2 from scratch, and server version, my bad. I just built 117.4 from scratch. This is the hash for it. And we just brought up a cluster on it, and we just validated that the cluster is able to start. But there's one more thing I want to show you here before we go on to another idea. Before we go on to the next idea, there's a couple things I want to show you. Go back to our notes here. So we did that. We did that. Yep. Also done. Oh yeah. Gimme is awesome. Hey, somebody put in a link here for me, okay? Because I keep forgetting to do that. So go get. We talked about go get. Super awesome. We talked about building stuff. Let's play. We've been playing. Let's talk about tests. What I wanted to show you was this. So first, before we do that, let's talk about the testing docs. These are actually really good, right? Running unit tests, how to set flags on unit tests. These basically describe like how to go about it and like like how to run all of the unit tests, how to set a timeout, how to run tests for just a specific area, right? And so let's play with this and figure out how to map this example to what we're doing inside of our kind build, right? Because what I want to make sure of is you've checked out the code, you've built the code, you've brought up a Kubernetes cluster, you are awesome. But how do we actually verify that the tests for that particular component are still passing? Let's go check it out. So I'm going to copy that. Boop. I'm going to come over here. Actually, before I do that, so remember, this is actually how we're running the test, or the build, right? Inside of this part, we have build run.sh make, right? And so this is that run.sh command right here, right? Now I'm in my checkout of Kubernetes. I've got my run.sh command. If I do run.sh, and I go ahead and paste that example in there. Whoops, I highlighted, my bad. Whoop. Bear with me. Docs, copy. Now these are unit tests. These tests are about testing that the code that is in the kubelet associated in package, right? So actually, let me just clear that up real quick. Boop. All right, so Kubernetes code layout. We have all these directories. The package directory is where a lot of the actual code is hosted for the Kubernetes stuff. And what we're looking at here to actually verify is we want to run all of the unit tests for the kubelet code. And the way that we can do that is using Go to do a Go test effectively of the code that's inside there, right? And so let's just go inside here real quick, inside of kubelet. Package kubelet. And inside of here, everything that you see that actually has like _test.go, these are actually, this is code that is going to be used to validate the functionality of a thing that is named just like it, but doesn't have test.go inside of it, right? So active deadline go, this is actually some functionality, and active deadline _test.go represents the tests that validate that functionality in the form of unit tests. Now, I'm not going to get too far into it. If you go into the testing directory again, or into that testing documentation that I was showing you here, they definitely get into like how to run tests, like how to write tests, those sorts of things. I'm pretty sure they get into that. And if they don't, that's something that, the community can definitely help with. I don't really have time to get into it here, but unit tests are important, right? Basically validating that your code works the way you expect. But the way that we run these unit tests is by basically using the same thing that we would do to build, but instead of using that make command to build the binaries, we're going to use that make command to test that code, right? So let's go ahead and do that real quick. Whoop, I don't know where it went. All right. So let's go back to directories. Now we're in the Kubernetes directory, right? So we're in our checkout of Kubernetes. We're on that tag still. Build run.sh, make test what equals package kubelet. And what this is going to do is it's going to do like a search for all of the test files under kubelet, and it's going to try and run them. And there's ways to actually filter that, but we're not going to get into them here. Now the output looks very similar to us, right? Like obviously there's a bunch of trash that shows up in the first part of it, but we're building a Docker image with the kube build image, and we're going to run this test inside of it. Ooh. Running tests without code coverage. This is basically like generating a bunch of the code that's necessary to do the testing, doing testing for API versions. And I mean, I hope I didn't like bite off too much here to actually achieve this, but I'd love to see the output of the test results. So let's take a look at that real quick. But the reason I'm bringing this up is because if you're doing development on Kubernetes and you want to change or modify the behavior of some functionality within some part of the project, right? You can still use kind and still do your tests against kind, right? So like the way that we're doing that today, I just checked out, like I'm just inside of the area where I've got my code checked out, my Kubernetes code, and I could just use build run.sh, make test, and then what I want to test, and it will actually test against the unit tests that are present in my code. So as I develop new functionality, as I write new tests for that functionality, I can validate that that's going to work before having to write a commit for this, right? And that's actually pretty killer. Like that's a pretty killer feature of how this works. All right. Now that's just unit tests. We can also do end-to-end testing, right? So it's not just unit tests. Sigs.k. I'm not going to go through the whole unit test. And in fact, I will actually take you over here again to our episode. So other things that you can actually do here. We're working on an issue inside of the kind project. Whoops. Did I miss something? Bum, bum, bum. Oh, I must not have linked it. One moment while I find the link real quick. Ben the Elder. Okay, so there we go. We're working on making it so that there's a kind subcommand that would allow you to test to run an end-to-end test for Kubernetes directly from the kind command line, rather than having to do it manually. This would actually just be an integrated part of kind, right? So if you wanted to do an end-to-end test, which means, because Kubernetes is effectively a distributed system, you want to actually validate that all of the functionality that Kubernetes provides, or maybe some subset of functionality that is related to the function that you're writing, actually works with all of the rest of Kubernetes. The goal here would be to actually provide a kind command that would allow you to run an end-to-end test for on top of Kubernetes and that would be just a built-in capability, which is pretty awesome. It's not done yet. You can see it's open. Ben is working on it, and Munners is working on it. I think Antonio is also working on it. I'm looking forward to this. It's really cool. But in the meantime, if you wanted to play with it, the way it works today, or could work today, right? Let's do my kind delete cluster. Inside of the hack directory, inside of your code, instead of your kind checkout, inside of CI, we can see these shell scripts, right? And one of them is e2ek8.sh, and the other one is e2e.sh. I think one calls the other, but let's take a look real quick. Yeah. So this one is actually going to go ahead and build kind and then run end-to-end tests against it. We probably don't have time to do all that, but well, you get the idea. Like, I would probably want to move that off of Bazel into something else. So right now it's the build type is set to Bazel, but the other option, there's another type of build. But this is a way to do it, and hopefully this is going to be made much simpler by just having a built-in kind command that does it. I'm not going to dig into it any farther. But you can also, one other way to run end-to-end tests, obviously, I'm not sure if everybody knows about this, is Sonaboy. Sonaboy is a way of running end-to-end tests as a deployed pod within your cluster, and it also packages up the entire end-to-end suite of tests in the form of a pod, and you can just deploy it, right? So if you wanted to do end-to-end testing this way, that is also in your ability. Now, the last thing I want to show before we all do, what does Bazel do? I'm going to let my friend Stephen Augustus handle that question, because he's such an awesome guy. I don't know if he's actually online right now, but like, touch on the status of node ports and metric server with kind. What does that mean by the status? Like, you can totally deploy them. Yeah. You can totally deploy metric server inside of kind. And then node ports are actually interesting. There's one gotcha about kind. This is a good point, and I'll bring this up. So if you're running kind against Docker inside of Windows or against Docker inside of Mac, then the challenge is that the way that Docker operates inside of those, so Docker for Windows and Docker for Mac, it doesn't actually expose the hosts at the command line level, right? So let me show you kind of explicitly what I'm talking about here. So I'll do kind create cluster real quick. Oops. Fine. All right, so kind create cluster. Now when I create this node to my own working environment, and we'll show kind of how that works real quick. Oh, I guess I'm downloading. You know what? I don't want to do that. Kind delete cluster. Image equals master. All right. Otherwise, what would happen is I have to download the kindest node v1.17.2, and ain't nobody got time for that. So let's just bring up a cluster with the cluster that we have. This is a caveat that I think is important to understand when you're troubleshooting things on kind, so I'm just going to cover it real quick. So we have kind get nodes, or not kind nodes is what it is, kind nodes. So, kind So we have one node is kind control plane, and if we do docker ps, we can see that image running, right? So this is our node that's running, and it's based on the image master, and this is the name of it, kind control plane. And if I do kubectl get nodes -o wide, we can see the IP address of this is 172.17.02, and I, on a Linux machine, can ping that. And that means that node pools or node ports are going to work the way that they always do. If I actually expose a deployment with a node port, then I'll just be able to hit that port directly, right? So if I, for example, if I jump into that kind control plane node, and I do ss-ln, right? Then I can see that it's listening on 2379, right? And that's like exposing effectively a node port. So from the underlying host, if I do that, if I do 172.17.02 colon 2379, I can connect to it, right? And to show that that's not just making stuff up, I can do 23.79.0. You see the exit code is 1. And if I do exit, I can see the exit code is 0. So NC-Z is just a way of validating that something is connectable, right? Using netcat to validate that the thing is connectable. So node ports on Linux work differently than they do on Mac and Windows, and that's because this IP address, right, ping 172.17.02, would not be available to me on a Mac or a Windows box. That doesn't really affect your ability to build or develop or test code around it. The most common of which is this, right? So we go to kinds.6.ksto. This is the documentation for it. And if you go into known issues, ingress, there we go. If you go into ingress, it'll describe how to expose this in a way that you can even use it on a Mac or on a Linux, right? So on ingress here, what we're doing is we're going to expose local ports to services running inside of our cluster. And so if we wanted to have like an ingress server or something like that, we can actually use this sort of a method to expose ports from our hosts right down into the underlying host, even on a Mac and on Windows. Because at this point, what we're doing is we're exposing the host port on the underlying host. We're exposing port 443, and we're mapping it to a container port running inside of Docker for Mac or Docker for Windows and connecting to it. So you can still map those connectivity things through. And there's plenty of other examples. Here's an example with Contour of how to do it. There's Ingress Nginx. So if you want to expose things and you're running on a Mac, there are examples of how to do that here. All right, what else did I want to cover? Let's go back to our checklist to make sure I haven't gotten too far afield here. We talked about tests. We talked about running end-to-end tests and running local tests. We talked about our power tool here, build/run.sh. That is so cool and such an awesome thing. Commit messages. Definitely worth talking about. I'm going to gloss over it real quickly. This is a great post by a guy named Chris Beams, a person named Chris Beams. I'm not going to make any assumptions. Chris talks about a good commit message, and as a maintainer of some stuff, I have to say this is actually like a totally great example, right? So when you're writing your commit message, summarize the changes in 50 characters or less, right? Wrote some change, changed the UX. Or did some, change this particular functionality, or, and sometimes it's even helpful to like give a path to a code base. Like if you made changes to kubeproxy, you might say like, brackets around the word kubeproxy, and then a summary of what the change is. And if you want to see more examples of this, obviously you can go to the code base and look at the other commits and understand what's in there, right? Look at open PRs, learn by reading. And that's the next part that we're going to actually talk about. Learn by reading is huge, right? Like being able to learn how to code or what code looks like or how to write tests or all of that stuff. because this is an open source code base, I cannot say this enough, right? I'm being super explicit here. Because this is an open source code base, there are examples of how to do or what the right thing looks like everywhere in this code base. If you want to learn more about how to commit to Kubernetes, or how to commit to any open source project, go and look at the other commits that are running inside of that code base, and you can learn basically just by reading. You can learn this stuff by reading, like seriously. So let's do that real quick, and then I think I'm going to call it at the end of the session here. So let me give you a practical example of what I mean by learn by reading here. So I'm going to kill my cluster. And I'm going to go to the Kubernetes code base. Kubernetes. Actually, I'm going to show you a little trick. Issues.k8s.io. Boom. So here's the issues for the code base. These are, and I'm going to look at pull requests. And here is update IPVS library to new repo and library version. So this is a pull request against master, right? Kubernetes master from Ricardo Katz. I think it's Ricardo, yeah. And we can see the files changed. There's a bunch of them. Basically moving some of the configuration off into a different place. It's updating the errors package, a bunch of other things. Let's try validating this real quick, right? So this is a checkout that Ricardo did, or a change that Ricardo did. We can see this is one commit. It's got everything in it. And we want to actually understand what the commit is and what the change is going to be. It's applied to Andrew Sai Kim. There's a change suggested by DIMS. Clearly there are some transitive dependencies that needed to be updated as well, so this needs to be double checked if it breaks anything. This is probably a lot to change, but let's go ahead and try it anyway. And what we're going to learn here is actually some interesting stuff. What we're going to learn here is how to check out the code of another contribution. We're going to switch to that code. We're going to build source code based on what we see. So let's try this out. And then this will be the last thing we do. cd go source k8s.io Kubernetes git remote add Ricardo. What was his name? R.I. Katz. R.I. Katz. I'm sure there's a better way to do this, but I haven't optimized it. Git at github.com. What I'm doing is I'm adding a new remote to my local checkout of Kubernetes. Right? And I'm going to do git fetch all. And now I can see the things that are both in my checkout and also on Ricardo Katz's checkout, right? And so if I do a paste, I can see the one that I'm interested in is this, issue 89109, right? So if I do git checkout, so now if I do git log, I can see that I'm on Ricardo's commit, right? This is his pull request, and this is the commit that he put in. So let's build Kubernetes from this source and verify that it works to some degree, right? So everybody knows how we're going to do that, right? We're going to do kind build node image name equals, I'm going to call it issue 81909. And here we're going to go ahead and verify that the code that Ricardo submitted is actually going to work upstream. And if we find any issues, we can comment on that. And this is a way for us to interact and contribute to what's happening in Kubernetes without necessarily writing code. I'm not writing code here. What I'm doing is I'm building a pull request that looks like a pretty complex change, and I'm just going to validate the behavior using end-to-end tests and those sorts of things. And then if it all works, then on you go, right? It's actually functioning correctly. So here we are, we're building the kubeadm, kubelet, and kubekettle. All right. And if this fails to build, then we'll actually be able to see this output here, right? Like if there's actually a bug in the code and it won't actually compile, then we would see the output of that here. But presumably, Ricardo got past that before he actually submitted the pull request, right? He actually had some way of actually testing that it would build locally before actually putting it up. So this is a way that we can actually improve perhaps even the user experience that Ricardo goes through. Y'all are awesome for hanging out with me. I know this is a long session, and I'm hoping that everybody's really getting something out of this, but yeah. It's incredible. Yeah. Again, we're the top of the, top of tree for kind right now is building this twice. I don't know why. That makes no sense. We should probably fix that up. We're almost there. While this is actually happening, I'm gonna pull up this thing I built for kind.k8s.work. So this is a slide deck I put together for the presentation that I did in San Diego. And it's awesome. But what I'm looking for, okay. What I want to see is, just bear with me for a second. I'm actually looking for a configuration. Wait, it's Maui Lion kind workshop. Workshop, build environment, kind config. So I want to pull this right here. And then we'll talk a little bit about what this is. Oh, image build complete. All right, so we got it built. Now, before we go any farther, cat cd tgik cat. Let's make it a new directory. IPVS testing, cd IPVS testing, cat config, paste, cd. Okay. Now I'm going to go back to my source directory. Now, what I would want to do first here is just do the unit tests, right? So make Control C, Control R, unit. All right. So I'm in my Kubernetes directory, right? Source.k8s.io Kubernetes. I'm on the checkout that Ricardo has provided, and I'm going to run my tests against kubeproxy. Except I don't remember what the name of that is. So ls package kube, is it dash proxy? No. It's proxy. Yeah. Okay. So kubeproxy is under proxy. There's a lot of that weirdness, but we'll go with it anyway. So when he's making his changes, we can actually even go look at his code and see where it's actually being committed. Much of it will be under proxy. And now we're actually doing a test of his code under proxy. So any of the unit tests that are defined under that level will be able to run locally and see that it works. So this is a way that I can contribute, right? So I can see, I'm going to run the unit test against it. I'm going to make sure it works. And then I'm going to bring up a cluster using IPVS mode. We saw that package proxy totally passed. That's awesome. All right, so let's go back to our directory here. IPVS testing. And I'm going to look at this configuration. And what's happening in here is I'm setting the mode for kubeproxy to IPVS. And the reason I'm doing that is because this is a change to the IPVS functionality, right? So I wanted to validate that that functionality is working. So let's go ahead and try this out, right? So I do kind create cluster config equals config image equals, not tab completed. That's maybe something I could add. What is the name of our image? It's issue 89109. So, can we build a Kubernetes cluster using the code that Ricardo submitted? Let's try it out. Things are looking good so far. Let's try it out. So let's do kubectl get run test image equals inanimate echo server port equals 8080. I'm really going to miss the run command, you know. Echo server port 8080. Boom. Kubectl get pods. We can see that pod is now running. Kubectl expose deployment. So now we have a new service defined called test. It's got an IP address. Things are working pretty good so far. Let's actually try to validate that things are going to work a little further. So let's jump into our, let's do kubectl get svc-o YAML. So this self-link here, right, is a thing that I'm going to show you all a trick that I use a lot. It's one of my favorites. Kubectl get raw proxy. So what this is going to do, this is kind of wild, is it's actually going to use the proxy endpoint of that particular service to interact with the pods on it, right? So if I do grep hostname, right, we can see that's our pod. And so now what we can see is that we're actually able to use that service. IPVS is not running on your MacBook. And you don't, Mozafar, because this is actually running inside of a Docker container, right? This is actually a Docker container running, and IPVS is happening inside of there, not inside of my machine, right? If I were to do IPVS ADM, I don't even have it. If I wouldn't be able to see that. I mean, I guess I would be able to see it because it's a Docker container running against the same Linux kernel. But inside of a Mac or inside of a Windows machine, IPVS is only a part of the way that that Docker container is running inside of your Moby container or something like that. And those things, I believe, are already built in. But if they aren't, it would be an interesting question. It would be worth validating. So I'm going to jump into my container here. IPv, yes. Apt update. This is something I need to add to the package list for kind. Apt install IPVS ADM. Yes. Clear IPVS ADM. So here we see our configuration for export kubectl config equals Kubernetes admin.conf kubectl get svc wide. So the IP address for our service is 10.101.159.194. Right, and so there is our deployment. There is our service being defined. And we can see there's only one currently healthy backend, 10.244.03. And if we do kubectl get pods, we can see that that is -o wide. That is this guy, right? So we can see that IPVS is configured. It is actually mapping back to a healthy backend. We can interact with it. It's all on a single node. And so the problem is perhaps this isn't going to work across multiple nodes. So let's go ahead and, we're not going to test that right now, but we could actually destroy this cluster, bring up a couple worker nodes, and validate that the service works across worker nodes as well, right? That's actually one of the other beautiful things about Kind, is that because right now we're just using a single node cluster, but if we wanted to validate, functionality that would require a multi-node cluster, we can still do that, right? So, that's the news. That's what I wanted to share with you. My goodness, that was a huge brain unloading into the screen. I hope that that was helpful and that we ended up with something useful. And I know that that was a ton of things to deal with, but I'm really liking what the notes look like so far. Well, except for that part. We don't want that. Okay. And then, yeah. So thank you. Y'all have a kickin' weekend and stay healthy and drink lots of water. And, I hope you all find some peace. That was my birthday wish this year, was that in these crazy times, I hope that everybody finds a little peace. I know that it's a lot happening right now. In fact, one of my favorite quotes from this week was from an email from my school that said, we understand that families have anxieties about the current situation. And I'm like, I think that's like a global thing right now. I don't think it's just families. I think everybody has anxieties about the current situation at the moment. And so be awesome to each other. That's all we can really do, right? Be awesome to each other. Remember that, even in the crazy times that we're in, everybody is going through something, right? You don't know what they're going through. They're probably having a hard time too. So take care of each other. I will see you all next time, and have an awesome weekend. Thank you all. Y'all are